All right, Chem Kids, welcome back. What kind of intro is that? This is one of the worst ones I've ever had. Last year, I had some pretty fancy animations. I don't have that yet, but I did have a former student of mine make a new intro for me. Wait, Bull Daddy? What is that? Uh, I mean, I don't know. This one might not work out after all. I gotta do some research. Week two. So a couple of us, we dropped calls, we dropped conferences, and it was sort of a disaster to make sense. So I thought it'd be helpful to have sort of a week one overview. Like, what do we have to know about week one? Well, for us, when we looked at week one, we were sort of talking, okay, in the scale of everything that we know, in the scale of what we need to actually take a look at, there are things that are extremely small, and there are things that are extremely big. Now, the examples that sort of ranged in between there, so we had atoms, which are like the smallest of smalls. And then we had things like planets, where are the biggest of bigs. And all I wanted you guys to walk away from with week one is being like, okay, I've heard the term atom before. I know they're really small, and I know everything is got made up of atoms. So living or non-living, things are made of atoms. And in order for us to communicate between these two, we often use scientific notation. So, for example, atoms are usually on the scale of 1.0 times 10 to the minus 10 meters in size. That doesn't really tell us too much because planets are more like 1.0 times 10 to the 20th meters in size sometimes. Now, that's getting a little bit too big. We start looking further, maybe it's like 10 to the 10th. That's still, we're not Jupiter. We're not the sun. So Earth would be like 10 to the 6th, 7th meters in size. But again, as I changed that, did it really make that much of a difference? I have a feeling that most of us are not super comfortable with scientific notation. And so as we kind of zone in this week, we're going to focus really hard on scientific notation and also the metric system. Because our idea here is if we can understand these two things, I can start doing things like drawing atoms. And so that's sort of our little like Jimmy Neutron atom idea, which is good enough for right now. And then I can also draw things like people. And we can have this concept of like, okay, well, how much smaller is an atom than a person? How much smaller is a proton than an electron? Because if I don't talk about these two things off the get go, it's not going to make any sense at all. So we had this weird conversation of like, what does it mean to touch something? And can we touch anything? And all I wanted you to do was start to get your brain wrapped around a weird idea. Because one of the hardest things about chemistry is you can't see it. I have to draw it for you constantly. So our takeaway from last week was really just this idea of we found out in order for us to have a conversation about small and really big, we need to get better at scientific notation and the metric system, which is what this week is going to really be dedicated to so that we can hopefully start drawing out the atom. And that's all we missed in our quick conversations.